Let me guess, you most likely have a laptop or computer lying around in your closet somewhere doing absolutely nothing. I had the same issue as well, and I totally get it. Sometimes computers are good enough not to be thrown away, but bad enough to scare anyone who tries to buy it from you. Now you're wondering, is there a way to still make use of that old computer? Can you somehow keep it useful in a world that constantly pushes you to upgrade to the latest hardware and subscribe to the latest services? My name is Russell. This is my IB Personal Project. My answer to both is yes. To prove that many people can still find value in older hardware, especially in the modern world, I took 5 pieces of tech abandoned by my family and challenged myself to see if I could build a simple ecosystem where all 5 devices synergize together to serve multiple tasks or support existing computer setups. Okay, I started the challenge easy with this 4th generation iPad that my aunt used to use. What I noticed was that despite being stuck on iOS 10.3, the screen is still like surprisingly good even on today's standards. I still think it holds up really well. I wanted to take advantage of the nice screen, so I installed Splashtop on both the iPad and the PC. As this did require iTunes drivers, otherwise the computer can't communicate to the iPad. It's a little bit annoying, but after that I plugged the iPad into the PC via Lightning to USB-A, and it immediately turned into a portable second monitor. I was able to drag and drop windows and apps and even enable touch input so that I could interact with Windows with my fingers. There was a noticeable amount of input delay when using a third-party monitor app, which is why I wouldn't really use this for gaming. I was also curious to see how a universal stylus would perform with this setup. However, because of the lack of palm rejection, my drawings were really miserable. Okay, that was easy. That's one device done already. After the success with the iPad, I decided to bring out the second Apple device, just this 13-inch MacBook Pro from 2011. I was told that this laptop was used in a beach by its previous owner, which is probably why the screen came absolutely cooked. I also found sand piled up in the exhaust when I tore this apart for the first time. But despite the obvious red flags, I have always wanted to try macOS, and I also happen to need a nice DVD drive to rip my CD collection. While I was installing an SSD to improve performance, I was surprised by how repairable and upgradable this old machine was. One back panel allowed me to access the battery, RAM, and optical drive, which made adding storage and RAM super easy, at least for me. This design was unlike modern MacBooks, which are extremely thin but also extremely easy to damage. Since I had removed the old hard drive, I needed a way to install macOS on the new SSD. Unfortunately, Apple's Internet Recovery, the software you need to do that, is dead and gone for this model. To make my life easier, I went ahead and bought a High Sierra USB installer and used that instead. I booted the Mac while holding the Option key to access the boot selection screen. I then selected the installer and was greeted with the High Sierra installer, which refused to use my SSD. I tried formatting the disk to macOS Extended first, but that didn't work either. So with a little help from my friends, I formatted the disk to APFS, then back to macOS Extended, and somehow that worked. Okay, so after creating a user account, I was greeted with a working copy of High Sierra. So this MacBook officially lost its support in 2017 with the release of macOS 10.3 High Sierra. It's the operating system I just installed actually. When the Mac reaches its end of life, it stops receiving security updates and patches, which does make them a bit more vulnerable nowadays. This is usually the main reason people upgrade to newer MacBooks. However, there is an option for those who still want to squeeze just a bit more life out of their MacBooks. That's when I discovered OpenCore Legacy Patcher, a piece of software that allows you to install newer versions of macOS to unsupported MacBooks. I built an OpenCore configuration, rebooted, and was able to boot into the OpenCore environment, download macOS Monterey, and install it. During installation, the laptop suddenly started having a seizure. That seizure was helpful because the beeping indicated a RAM issue, so I shut the MacBook down, opened it up again, and removed one of the RAM sticks. After rebooting, I was able to successfully get into macOS Monterey, skipping the entire installation process. I then ran OpenCore's root patches to properly configure the hardware and installed apps like Obsidian, Anki, and SingThing, which is what I usually use to study and sync my notes in class. I also installed XLD to rip my CD collection into FLAC files for archival. I actually ended up really liking the MacBook for studying, because yes, it's a really slow computer, but to me, that's kind of a plus. I cannot study in the same computer that has my entire Steam library with just enough power to study but not enough power to play games. This allowed me to separate myself from distractions when I really need to just sit down and write. In fact, the script you are hearing from me was written on this Mac. And hey, I also got a sick new DVD drive. Okay, time for the laptop you saw in the introduction. This Acer V5 171. This one was used in a factory, so yeah, absolutely obliterated. The battery's dead, the plastic frame is ripping off, the keyboard's terrible, the trackpad's terrible. I do like the form factor, but yeah, I knew that even for something as simple as studying, this will not cut it. It's already falling apart. However, what's not falling apart is the internals of the laptop, because surprisingly it's still perfectly functional. I decided to turn this into a low-power network manager using Proxmox. Proxmox is an operating system that basically splits one computer into tiny containers that run services individually. I already have Proxmox loaded in a USB drive, so all I have to do is boot to it and install. After plugging in the laptop to power and Ethernet, I connected the USB drive and accessed the laptop's BIOS by spamming F2. I then adjusted the boot priority to boot into the USB drive and rebooted. I ran the Proxmox installer, made a root account, made up a hostname, and got into a terminal. I set up a DHCP reservation so the Acer would always receive the same IP address each time it connects to the network. After confirming this worked, I accessed the Proxmox web interface and used community scripts to install Pi-hole and Tailscale. Pi-hole acted as a network-wide ad blocker by filtering DNS requests. After setting it as the router's DNS server, all devices on the network became ad-free instantly. However, ads returned when I switched to mobile data, since switching to mobile data brings the device out of the local network. To fix this, I used Tailscale to securely connect my devices back to my home network from anywhere in the world. After configuring it, I was able to browse the internet on cellular data with no ads. I also installed Uptime Kuma for monitoring, just as a proof of concept and since I had extra resources in the Acer. Now, I thought I was done with the Acer until I closed the lid and all these services crashed. So I opened laptop back up and modified the login.com file and setting the laptop to ignore lid closes. That does make the laptop use a bit more power since the screen stays on, but that also means that I can conveniently store this laptop anywhere while it was still running. For our fourth device, it's this old desktop computer that my parents used to daily back in 2013. It really needed a good way to justify its high power draw and high noise levels. To get the most out of the flexibility of the computer, I decided to turn it into a network attached storage, or a NAS. A NAS is basically able to attach files onto your local or home network so that any device connected to that home network can access the files. Think of it as an external USB storage device that can magically attach itself to all the devices you use. I removed the GPU since the Pentium G 2010 had integrated graphics somehow. This also helped reduce power consumption for 24/7 operation. I then removed the 160GB hard drive and replaced it with two WD-RED 1TB drives. Finally, I added a small 128GB SSD to act as a boot drive. When setting up a file server, it's always good practice to keep the operating system separate from the main data pool. You might be wondering, why did I install two 1TB drives instead of just installing a single 2TB drive? Well, this was a way for me to test this thing we call RAID. RAID allows you to combine multiple hard drives into a single unit we call a pool. In this scenario, the two 1TB drives are storing the exact same data. So I'm basically halving my capacity to 1TB. That might seem a bit weird at first, but that basically means if one drive dies a perfect copy of the data will exist on the other drive. This is super important for file safety since I plan to run this computer 24/7, and it's nice to have a bit of redundancy. I closed up the PC, connected it to power, video, and LAN, then went straight to the BIOS to boot from my Vento drive again. After changing the boot priority, I rebooted only to realize I forgot to save my changes. After fixing that, I finally booted into Vento and ran the prepared Open Media Vault installer. It first asked for a DHCP hostname so that it could be easily identified by the router. Then it asked for a domain name, which just said it could make something up, so I made somethingup.com. After setting a password and time zone, I selected the 128GB SSD as the boot drive and completed the installation. I also made sure to assign a static IP to the NAS so that it would be reachable in the same place by other devices. The recommended way of getting RAID to function in OMV right now is to use a plugin that enables MDADM. The process seems simple. I SSH'd into the server, pasted a command, refreshed the interface, and installed the MD plugin. But then I was greeted with a horrifying error screen that just asked me to left click. After left clicking, I could access the drives tab, but the error kept returning. So I went back to the terminal, reinstalled the plugin, and manually ran MDADM to enable RAID, along with restarting Nginx to fix the interface. With that fix, I assigned the two 1TB drives into a mirrored RAID pool and applied the changes. Once everything was set up, I typed the server's address in File Explorer, inputted my credentials, and was able to successfully access the storage share. To test performance, I transferred some CD files and saw speeds of up to 100 megabytes per second. I was even able to play music directly from the NAS without stuttering. I even tested larger files, including video footage, and while speeds were slower, playback was still usable. On my iPad connected over Wi-Fi, I logged into the server and was able to view and play the same files, albeit with a little bit of lag. Now for the ultimate test. I pulled out all of the hard drives mid-transfer. Despite the drive disappearing in Open Media Vault, the server was still able to play all the media and serve all the files as if nothing happened. Now here's where the ecosystem starts falling into place. Remember the network manager I made earlier? That allowed me to tunnel back into my home network from anywhere in the world? I decided to test it. In a moving car, I connected my iPad to my phone via hotspot and was able to open and view all the files that I stored in previously outside the local network inside a moving vehicle. Remember those CD files I ripped earlier with the MacBook? I was able to listen to the music without downloading them on my phone. With zero additional subscriptions whatsoever, I was able to build my own external cloud storage and even stream my own media privately. Okay, the last device. This video is already getting really long, but here it is. The Samsung J5 that my grandpa used to use. I actually thought of what I wanted to do with this for a really long time because the phone still works, but it's kind of missing a power button and it's been getting really slow the more updates. Yeah, nowadays it's kind of nice to have a reliable phone so that you can stay in touch. But despite all of that, this was given to me by my grandpa for completely free. I had to save it. I decided to open the Play Store, wait eons for it to load, and install MacroDeck. I then installed MacroDeck on my desktop as well, and used a QR code to connect the two together. I then added some Windows hotkeys for testing and assigned them to buttons which directly showed up on the phone. Okay, see where this is going? After making a few more hotkeys, this phone became a shortcut macropad similar to the Stream Deck that allowed me to simplify shortcuts into a single button. I used the very video you're watching right now to test manipulating the timeline and saw near perfect response times. So to summarize, yes, old hardware can be repurposed to serve functionality that would otherwise cost way more to run with new hardware. The question is whether you should build a project like this. If you're a casual user with hardware already lying around somewhere, this is probably the best way to extract every little bit of value left in these systems. It also helps reduce your e-waste output, which is another huge plus in my opinion. Since we're dealing with old technology that might fail, of course, since they're old, go ahead and try building something like this and let it run for a few weeks before you decide on whether you want to commit to this or seek better alternatives. And yeah, that's about it for today's video. Thank you so much for watching my IB Personal Project final product. It really means a lot to me. Yep, I'll see you. I don't know. I don't have an upload schedule. So, bye bye.